Hi there, so this is lesson 14.3 on compound measures then. It's the second part of the lesson on compound measures, and in this lesson we are focusing on density. So our objectives then for today: to be able to solve problems with compound measures, to be able to find density, mass and volume, and to be able to convert between measures of density. Before we start, we need to check our prior knowledge. So we need to be able to convert between metric units of mass. So we need to know that 1 kilogram is equal to 1,000 grams. You also need to be able to convert between metric measures of volume. Now this is a little bit more complicated, so just make sure you look through that carefully. So 1 kilometre cubed is the same as 1,000 times 1,000 times 1,000, which is 1 billion metres cubed. If I want to change meters cubed to centimeters cubed, there are 100 centimeters in a meter, and it's cubed, so it's 100 times 100 times 100, which is 1,000,000 centimeters cubed. And finally, from centimeters cubed to millimeters cubed, there are 10 millimeters per centimeter, and again that needs to be cubed, so 10 times 10 times 10 is 1,000 millimeters cubed. Now I'll put in a diagram at the bottom here just to remind you. So when I want to find volume, volume is length times width times height if we're looking at a cuboid. So if our cuboid is 1 by 1 by 1, a cube, then we would get 1 times 1 times 1 is 1 meter cubed. Now if I change 1 meter into centimeters, I would multiply by 100. There are 100 centimeters in a meter. So each of my sides that were 1 meter are now 100 centimeters. So if I find the volume of my cube, my length times my width times my height, I would need to do 100 times 100 times 100, which is 1,000,000 centimeters cubed. So you can see why that works. So when we're changing between a single length, from meters to centimeters, we times by 100. But if we want to do that for volume, volume is in 3 directions, so we need to do it 3 times. So rather than just multiplying 1 times 100, we need to do our 1 times 100 times 100 and times 100 again. Okay, pause the video now if you need to make a note of those. We're going to be using these values throughout this lesson, so it's really important you have a good understanding of these before you move on. Okay, so today we're going to have a look at density then. So just to clarify what density is. So, as it says there then, density is a word we use to describe how much space an object or substance takes up, its volume, in relation to the amount of matter that an object or substance has, so its mass. So another way to put that is that density is the amount of mass per unit of volume. And if an object is heavy and compact, it has a high density. So you will also have looked at density in science. So this perhaps is similar to one of the sorts of experiments you might have done. So it's a good idea to have a look at this and see the density of different things. It gives you a good way of understanding density. So at the bottom here we've got our bolt. Now a bolt is made of metal. So metal is quite heavy, so it has a high mass, but it's quite a small object. So it has a low volume. So if we've got a high mass with a small volume, that makes an item really dense. As we work our way up, we get less dense. So these are literally floating on top of each other. The green layer here is water. It's just been coloured green so you can see it. So you can see everything that's below that green water there is heavier than water, is more dense than water. Okay, that's why it sinks to the bottom. Anything that's above the green here is less dense than water, which is why it floats. So we should know that oil floats on top of water. It is less dense. We've also got things like a plastic bottle top here, and right at the top we've got our ping pong ball up here. So our ping pong ball is really light. It doesn't have much mass to it, but it's a larger volume. Its surface area there is larger, making it a larger volume as well. So that's why it's floating. Okay, so hopefully that's given you a bit more of an idea about what we mean by density. So we're looking then at compound measures. So a compound measure is made up of 2 different measures. So density is a compound measure. It's measured in grams per centimetre cubed, or kilograms per metre cubed. Now hopefully you will have seen this triangle before, or these types of triangles. At least you should be using these in science as well. I know they use these quite a lot. But it's a good way of quickly seeing how we can find the different formulae that we need to use for density, mass and volume. So let's start off with mass. If I want to find the mass using this triangle, I would cover up the word mass at the top here, and I'm left with density next to volume. When things are next to each other in these triangles, they're multiplied. So our mass is equal to the density times the volume, and our mass is measured in grams or kilograms. If I want to find the density, I would cover up the word density, and I'm left with mass over volume. When one thing is over another, it means we divide it, so we get mass divided by volume. So that's our compound measure, and it's in grams per centimetre cubed or kilograms per metre cubed. Finally then, if I want to find volume, if I cover up the word volume, we've got mass over density. So mass divided by density, and that's measured in centimetres cubed or metres cubed. So you can see that our compound unit here is a mixture of the values here, grams and centimetres cubed or kilograms and metres cubed. Okay, if you need to, please pause the video now. It's worth making a note of that triangle and the different formulae that we're going to be using today, as well as making sure you understand the units of measure for each of those things. Okay, so let's see how it works in practice then. So we've got a piece of metal that weighs 40 grams. So they'll often use the word weight for mass in maths questions, so that's something to get used to. So we've got the mass really of 40 grams and a volume of 4 centimetres cubed, and we want to know what is its density. So starting off then, let's draw our triangle. So we've been asked to find the density, so we're going to cover up the word density, and we're left with mass over volume. So that's mass divided by volume. So 40 grams divided by 4 centimetres cubed will give us 10 grams per centimetre cubed. Okay, so we need to make sure we get our units right for our answer there. All right, number 2 then. What's the volume of a piece of rock that has a mass of 72 kilograms and a density of 9 kilograms per metre cubed? So this time we were asked to find the volume. So again, we'll have our triangle, we'll cover up the word volume, which gives us mass divided by density. So we've got the mass of 72 divided by the density of 9 kilograms per metre cubed, and that gives us 8 metres cubed. So again, make sure we've got the right units. So whatever units we were using in here for volume, we're making sure we use here for volume. So we're checking our units are the same throughout. And finally then, gold has a density of 19.3 grams per centimetre cubed. A gold coin has a volume of 28 centimetres cubed. How much does it weigh? So that's the mass. So we're going to cover up mass. To find mass, we do density times volume. So density of 19.3 grams per centimetre cubed times 28 centimetres cubed gives us a mass of 540.4 grams. Okay, make sure you're happy with those before you move on. Okay, so your turn. So there are 4 similar questions there for you to have a go at. It is worth drawing out the triangle, and you can just cover up the appropriate words with your finger so you don't have to draw the same triangle out 4 times. Okay, let's have a look at the solutions then. So for the first one, we've done 150 divided by 60. We wanted to find the density, and density is mass divided by volume. So that's 2.5 grams per centimetre cubed. For the next one then, we're asked to find the volume. So to find the volume, we do mass divided by density. So 15.75 divided by 10.5 is 1.5 centimetre cubed. So we've just got to make sure we get these the right way around, making sure we read our numbers carefully. For the next one then, we want to find the density. So density is mass divided by volume. So the mass part of that was 14.7 divided by a volume of 7.5 is 1.96 grams per centimetre cubed. And the last one then, we were asked to work out the mass. So mass is density times volume. So we can do 7,700 times 2.5, which is 19,250 kilograms. Pause the video if you need to, make sure you're happy with all of those answers before you move on. Okay, we're going to have a look now at some problem solving. So we've been told the density of aluminium and the density of lead, and we've been given the volumes of each as well. You're asked which of the two blocks has a greater mass and by how many kilograms. So pause the video now and have a go at that, see if you can work through that step by step. Okay, so when we're working out problem solving questions then, it's really important how we set out that work. It makes it really clear for us, and it also makes it clear for anybody marking it what we've done. So first of all then, we've been asked to find the mass. So using our triangle to find mass, we need to do density times volume. So we're going to do that for each of the different metals. So we'll start with the aluminium. So the aluminium had a density of 2,590 kilograms per meter cubed, and it had a volume of 0.5 meters cubed. So making sure we've used aluminium with aluminium together. That gives us 1,295 kilograms. We'll do the same with the lead. So the lead had a density of 11,400 kilograms per meter cubed, and its volume was 0.1 meters cubed. So we've multiplied those, 1,140 kilograms. Now our question asked us which had the greater mass and by how many kilograms. So we've got to find the kilograms difference between them. So we're going to do 1,295 minus 1,140. So there are 155 kilograms difference between them. And finally, we need to give our statement then for our answer. So when we're asked one of these long worded questions, we need to give a sentence answer at the end, a conclusion to what we found out. So which of the blocks had a greater mass? Well, we can see that that's the aluminium, and by how much? 155 kilograms. So a nice clear sentence at the end then, aluminium has a greater mass by 155 kilograms. Okay, so we're going to move on then to have a look at converting units. So all of the questions we've had so far, we've used the units from the question in our answer. But sometimes we're given the information in one type of unit, but they want our answer in a different unit. And that means we need to change between those units before we start working with them. So it's easier to do the changes at the beginning of the question rather than trying to change the units later on. So let's have a look at what I mean by that then. So we've got a sample of brass, has a mass of 2 kilograms and a volume of 250 centimeters cubed. What is the density in grams per centimeter cubed? So we can see then we've been given our mass in kilograms. We're asked for our answer in grams. The volume is in centimeters cubed and we're asked for centimeters cubed. So our volume is okay, that's in the right unit, but our mass is not. We've got 2 kilograms and they want an answer in grams. So our first step is to change our mass from kilograms to grams. So 2 kilograms to get from kilograms to grams. Remember, kilo means 1,000. So we times 2 by 1,000, giving us 2,000 grams. Now we've got all of our numbers in the right units, we can work that out. So again, with our triangle, we're asked to find density. So that leaves us with mass divided by volume. So our new mass in grams then is 2,000 divided by our volume of 250 gives us 8 grams per centimetre cubed. So we've given our answer in the units that they've asked us for. Okay, let's have a look at another example just to make sure we're okay with it. So a cubic metre, so that's 1 metre cubed of concrete, weighs 2,400 kilograms. What's the density of concrete in grams per centimetre cubed? Okay, so we've got 1 cubic metre, which is 1 metre cubed, and we're asked for centimetres cubed. So that needs changing. And we've been given a weight in kilograms, and we're asked for 1 in grams. So that also needs changing. So we're going to change those one at a time. So 1 cubic metre then is 1 metre cubed. We need to change that to centimetres cubed. So remember, we need 100 centimetres per metre. So we've got 1 times 100 times 100 times 100 again. When it's cubed, we've got to multiply it by 3 times. So that gives us 1 million centimetres cubed. So hopefully you've got that noted down from our prior knowledge page earlier. We now need to change the kilograms to grams. So 1,000 grams per kilogram. So we're going to multiply 2,400 by 1,000. So that gives us 2,400,000 grams. Now we've got our weights in the right units, our measures in the right units there, we can now find the density. So again, we were asked to find density, so that's the mass divided by the volume. Our mass this time is 2,400,000 and our volume is 1 million. So if we divide those, we get 2.4 grams per centimetre cubed. So with these questions, you may just need to change one of the units. You may need to change both of the units. So check what units you were given in the question and what units they would like your answer in, and change them before you do any multiplying or dividing. Okay, so again then, 3 questions there for you to have a go at. So look carefully at the units, decide do you need to change one of the units or both of the units, and then use the triangle to help you decide if you're multiplying or dividing. Make sure you get those the right way round. Okay, let's have a look at the solutions then. So for the first one, we needed to change 10 kilograms into grams because we've been given here a volume of liquid to the nearest whole number, and we've been given this unit here in grams per centimetres cubed, so we need them to be the same. So we've changed 10 kilograms is 10,000 grams, and then we can divide by 1.18 to get 8,475 centimetres cubed. For the next one then, again, let's check our units. So we've got metres cubed here, but we've got centimetres cubed here. So we're going to need to make sure we change our metres cubed into centimetres cubed before we do any multiplying or dividing. So 0.05 metres cubed then. So we're going to multiply that. Remember, we've got centimetres cubed, we've got to multiply it by 100, then 100, then 100 again. So that's 50,000 centimetres cubed. And now we wanted to find the mass, so that's our density times our volume, which gives us 320,000 grams, or if we want to at the end, we might want to change it back to kilograms, so we can divide the grams by 1,000 to change it back to kilograms. That's up to you. Finally then, this one, we've been given a mass in meters cubed and a volume in meters cubed and a mass in kilograms, and we want our answer in grams and centimeters cubed. So we're going to have to change both of them this time. So if we change 3 meters cubed, we get 3 million centimeters cubed. And if we change our 21,840 kilograms into grams, we get 21,840,000 grams. Now we can work out our density. So remember, density is our mass divided by our volume, and that gives us 7.28 grams per centimetre cubed. Pause the video, make sure you've checked through those answers and you're happy with those values. Okay, reasoning then. So this is a sort of real life sort of question where we've got to make a decision about something. So Mr. Dixon is building a toy boat for his son, and he has 3 different planks of wood to choose from. So we've been given 3 different planks. Now you'll notice for each plank, the first one we've been given the volume in centimetres cubed and the mass in grams. The second one we've been given the volume in metres cubed and the mass in kilograms. And the third one, plank C, the volume is in centimetres cubed and the mass is in kilograms. So we've got a whole mixture of units there, so we'll need to decide which units we want to use. It said if the wood has a density under 1 gram per centimetres cubed, it will float. Which plank of wood is most suitable, and explain your answer. All right then, so again, any sort of problem solving, reasoning type task, we need to set it out nice and clearly. So remember, we're trying to find the density. So start off with our triangle. To find the density, we do the mass divided by the volume. So we need to do that for each of the 3 planks. But we need them in consistent units. So We're told here that we want to find out if we're under 1 gram per centimetre cubed, so we need to use grams and centimetres cubed. So if we start with plank A, we have grams and we have centimetres cubed. So we can start off straight away with plank A doing the mass divided by the volume, which gives us 1.2 grams per centimetre cubed. Now plank B then, we want grams, but we have kilograms, and we want centimetres cubed, but we have metres cubed. So we're going to need to change both of those before we can start doing our calculation there. So for plank B, if I want to change 0.0152 metres cubed, remember I need to times that by 100, then 100, then 100 again, which gives me 15,200 centimetres cubed. So use your calculator for these sorts of calculations. For the mass then, we want to change 7.6 kilograms into grams. So from kilograms to grams, we times by 1,000. So 7.6 times 1,000 is 7,600 grams. Now we have the right units, we can now find the density. So the mass divided by the volume, so the mass, the grams, divided by our volume here, which gives us 0.5 grams per centimetre cubed. Finally then for plank C, our volume's in centimetres cubed, that's great, that's what we needed, but our mass is in kilograms and we want it in grams. So we've only got to change one value this time. So if we change our mass, remember times it by 1,000, I get 1,020 grams, and now we can use our formula mass divided by volume, which gives us 1.02 grams per centimetre cubed. Now our question said it needs to be under 1 gram per centimetre cubed. So plank A, that's more than 1. Plank B, 0.5 is less than 1. Plank C, 1.02 is still more than 1. So which plank of wood is most suitable? Plank B is the only one that's under 1 gram per centimetre cubed, and we have to explain our answer. So he should use plank B, as the others are over 1 gram per centimetre cubed, so will sink. Okay, so to be able to float, it needed to be less, anything more, and it will be sinking. All right, pause the video if you need to. Make sure you've made a note of that. So again, whenever we're doing problem solving or reasoning type tasks, setting the work out nice and clearly, looking through the units really carefully, making sure we've got everything we need to make the right decision at the end. Okay, finally for today then I'm going to leave you with a challenge. So material A has a density of 5.8 grams per centimetre cubed, and material B has a density of 4.1 grams per centimetre cubed. 377 grams of material A and 1.64 kilograms of material B form material C. So we're going to put those together to make a new material C. Work out the density of material C, give your answer to 1 decimal place. So pause the video, have a go at the challenge, see how far you get. Again, remember, set your work out carefully in small chunks. It makes it easier for you to follow and to then check if there are any errors. Okay, so the key to answering this question then is to realise that to be able to find the density of the new material, we actually need to have the total volume and the total mass. Okay, so remember, density is mass divided by volume. If we want that for the new material, we need the totals for both of those, and we can't just add these units together. It doesn't work in that way. So let's start off with material A. So we know its density and we know its mass. So the only thing we don't know about it is its volume. So let's find material A's volume first. So for material A then, there we are, material A, we had 377 divided by 5.8 gave us a volume of 65 centimetres cubed. Okay, now we need to do the same for material B. So for material B then, material B was in kilograms and we wanted it in grams, so we've just changed that up here to 1,640 grams, so we can use that for material B. So the volume of material B, 1,640 divided by 4.1, its density, gave us 400 centimetres cubed. So now we can find the total volume. So if we add those two together, the total volume of material C is 465 centimetres cubed. So remember, to find the total density, we need the total mass divided by the total volume. So the total mass is 377 plus 1,640, so 2,017 grams. And if we do that total mass divided by the total volume to give us the density, it is 4.3 grams per centimetre cubed. Okay, so well done if you managed to do any part of that challenge. Okay, if you got it all right, that is absolutely fantastic. These are quite tricky questions, but worth having a go at to practice. Okay, well, thank you for working on that lesson with me today then. Next time we'll be looking at speed, distance and time. So again, using those similar types of triangles to be able to find speed, distance and time. Look forward to seeing you then.